Hello and welcome back. We are continuing with our basic review of sinusoids. Most of these materials should be review for you, but if it is not, well, watch the videos. So in this activity, we are giving a sinusoid x of t equals 20 cosine of 2 pi 40t minus 0.4 pi. And we are asked to plot this sinusoid. Now, if we didn't have a phase shift, to do a sketch, manual sketch of the sinusoids will be quite trivial, right? We will say, okay, if we don't have a phase shift, we have an amplitude of 20 minus 20, so our x of t will be, and in order to, you have to show that it has 40 cycles in 1 second, and so what we will do is we need to determine that first peak there, and we'll say, well, that, since that's the period, is going to be 1 over my frequency, right? So remember, there's an inverse relationship between the period and the frequency. 1 over 40 seconds. And boom, we are done. Now, in this case, however, we have a phase shift. And we already saw in the previous video the relationship between phase shifts, the relationship between time shifts and phases. So you have a phase minus 0.4 pi. How much does it shift that first peak? Meaning we have to draw this like how much is that shift? What is the relationship between the time shift and the phase shift? Right? Because we will need to determine the location of the first peak in order to really properly sketch this signal. So as we saw, the relationship is that we have between phase and time is given by the radian frequency. And so in this case, we have our phase is minus 0.4 pi equals, and our radian frequency is 2 pi 40. This is T1. You solve for T1 in this case to determine that location of the first peak. We see that we have minus 0.4 pi divided by 2 pi times 40, or 0.005 seconds. And so, to properly sketch the signal, this is what we will do. We have to determine the location of the first peak, so the amplitude, 20. The location of the first peak sketches this part of the signal, which is 0.005 seconds. And then that plus 1 over 40 will give us the location of the second peak, which determines this period. So 1 over 40 plus 0.05, or what is 0.003, just double check it, doing this mentally. And we have a sketch. Now this is very basic. Recall what we are doing here is just getting used to sinusoids, their manipulation, being able to quickly sketch them. Why? Because they are the fundamental signals, the fundamental building blocks of all other signals. And so you need to be very comfortable with sinusoids and their properties and their manipulation. And one of the things that often you will need to do is, in your head, or in back of the envelope sketch, if you're giving a sinusoidal signal with phases, etc., be able to sort of sketch it, just to be able to check results that you may see in MATLAB, in any other simulation software, or the results of an implementation. Thank you.